Hello everyone. Today I am here with you all with 6th chapter of class 9th maths, that is lines and angles. We are already having videos on the first 5 chapters of class 9th maths. So let's start with the 6th chapter of class 9th maths. Before starting with the chapter, let's see some of the terminologies related to the chapter. So first is your line segment. The line segment is a part of line which is having both the endpoints. That means it is a part of a line where both the endpoints we are having the starting point also, we are having the ending point also. That means if one of the point is your A, another point is your B, then this will be your line segment AB. We can measure the length of a line segment because it is having a fixed length starting from here, ending at here. So it is having a fixed length. That's the reason we can measure the length of a line segment. The line segment AB will be denoted as AB, and over here we'll be making a line. It is having the starting point also, it is having the ending point also. Then comes your ray. If the part of the line is having only one endpoint, another endpoint it is not having, then it is known as your ray. That means starting point of the ray we are having, suppose it is your A, but in this direction it can be extended up to whatsoever the length we want. So if a part of the line is having only one endpoint, then it is known as your ray. Suppose this is your ray AB, so ray AB will be denoted as AB. Over here we'll be making an arrow. So this is the denotion of a ray AB. We cannot measure the length of a ray AB because it is not having any fixed length. Now comes your line. Line is having not even a single endpoint. Means it is not having the starting point also, it is not having the ending point also. In both the directions it can be extend up to whatsoever the length we want. So because it is not having the fixed length, we cannot measure the length of a line also. In both the direction we can extend it up to the length whatever we want. Now, so the denotion of the line is your AB. This is a denotion for a line. So we can only measure the length of a line segment. We cannot measure the length of a ray also. We cannot measure the length of a line also because they are not having any fixed length. They can be extended in the directions. It can be extended in this direction, only one direction, and it can be extended in both the direction. Now let's come to your collinear points. If there are 3 or more than 3 points through which we can pass a line, then such type of points are known as collinear points. If minimum of 3 points should be there, if there are 3 points or more than 3 points through which a line can pass, then such points are known as your collinear points. There could be more points also. Suppose this is even a point D. So through all these A, B, C, D, we can make a line which will pass through all these 4 points. So such type of points are known as your collinear points. Non-collinear points. If through the given points, that should be minimum of 3 points should be there, we cannot draw a single line passing through all 3 of them, then such type of points are known as your non-collinear points. Suppose these are the points. Pass from these 2, we can make a line. From these 2, we can make a line which will pass through these 2. From these 2, we can make a line. But we cannot make a line which will pass through all 3 of them. That's the reason these type of points through which we cannot make a line which will pass through all 3 of them, or it could be a more than 3 point also. Such points are known as your non-collinear points. Then comes your angle. So what angle is? If we are going to take 2 rays which are originating from the same point, that means if the end points of both the rays is same, then an angle is formed. This is your angle. Here there are 2 rays is there. Suppose this is your A, this is your B, and this is your C. So ray AB is there and ray AC is there. For ray AB and AC, your endpoint is same, that is your A. If we are having 2 rays whose endpoint is same, then they are forming a angle. Over here, these are known as your AB and AC are known as your arms of the angle, and your A, the fixed vertex, the fixed point through which they are originating, the rays are originating, is known as your vertex. So point A is the vertex, which is the point from which your rays are originating, and AB and AC are known as arms of the angle. Now let's see what is types of angles. Types of angles according to the measurement of the angle. So we already know that there are acute angle is there, your right angle is there, obtuse angle is there, straight angle is there, reflex angle is there, complete angle is there. All these are the types of angles according to the measurement of the angle. If the measurement of the angle is less than your 90 degree, if measurement of the angle, this will be something like this type of angle will be there. If the measurement of the angle, suppose this is your x, if the measurement of the angle x is greater than your 0 and less than your 90, if the measurement of angle x is greater than 0 and less than 90, then such type of angles are known as acute angles. Then comes your right angle. If the measurement of the angle is exactly 90 degree, if suppose this is your angle x, if the measurement of the angle x is exactly 90 degree, then such type of angles are known as right angles. Then comes your obtuse angle. This will be the type of the angle. Suppose this is your x. So if the measurement of the x is greater than 90 degree, but it is less than your 180 degree. If measurement of the angle is greater than 90 degree and less than 180 degree, then such type of angles are known as obtuse angle. Then comes your straight angle. If the measurement of the angle is exactly 180 degree, suppose this is your x, if the measurement of the angle is exactly 180 degree, then such type of angles are known as your straight angle. Then comes your reflex angle. Reflex angle will be, suppose this is the reflex angle. These are the two rays, and if we are considering this angle and this is your x, so this will be the reflex angle. So reflex angle will be the angle whose value will be greater than 180 degree but less than your 360 degree. If the measurement of the angle is more than 180 degree and less than 360 degree, then such type of angles are known as reflex angle. Then comes your complete angle. So if the measurement of angle is exactly 360 degree, then it is your complete angle. The measurement of the angle is exactly 360 degree, then it will be a complete angle. So the types of angles according to the measurement is your acute angle, right angle, obtuse angle, straight angle, your reflex angle, complete angle. If the measurement of the angle is more than 0 but less than 90, such type of angles are your acute angle. If the angle is exactly 90, it is your right angle. If the angle is more than 90 but less than 180, it is your obtuse angle. If the angle is exactly 180 degree, it is known as straight angle. If the angle is more than 180 but less than 360, then it is your reflex angle. And if the measurement of the angle is exactly 360 degree, then it is your complete angle. Now let's talk about some pair of angles. First of all, it is your complementary angles. If there are two angles whose sum is equivalent to 90 degree, then such type of angles are known as your complementary angles. That means if there are two angles, suppose x and y, and their sum is coming equivalent to your 90 degree, then such type of angles are known as complementary angles. Example I can take, suppose I am saying if one of the angle is your 30 degree. So what will be the complementary angle of this 30 degree? So if I am taking the value of x to be 30, so I can write 30 plus y is equivalent to 90 degree. So we can say y will be 90 minus 30, that is your 60 degree. That means complementary angle of 30 degree will be your 60 degree because sum of 30 and 60 is equivalent to your 90 degree. If I am going to say that what will be the complement of itself, that means what will be the measure of the angle for which the complementary will be the number itself. So if I am going to say, that means both the values of x and y will be your same. So instead of writing both separately, I can write it to be x plus x is equivalent to 90 degree, or we can say 2x is equivalent to 90 degree, or we can say x is equivalent to 90 by 2, that is your 45 degree. That means for the angle 45 degree, the complement angle will even be your 45 degree because 45 plus 45 will be your 90 degree. Now coming to your supplementary angle. So if there are two angles, the sum of which is your coming equivalent to your 180 degree, then such type of angles are known as supplementary angle. Suppose I am going to take an example of, suppose your value of x1 of the angle is your 60 degree. So what will be the supplementary angle for this 60 degree? So we can write it as 60 plus y is equivalent to 180 degree, or we can say y will be 180 minus 60, that is 120 degree. That means for the 60 degree angle, the supplementary angle will be 120 degree, because sum of 60 and 120 is equivalent to your 180 degrees. Now, if again I am going to say what will be the supplementary angle of itself, that means both the supplementary angle should be same. So in that case, instead of taking two separate variables, I can say x plus x is equivalent to 180 degree, or we can say 2x is equivalent to 180 degree, or x is equivalent to 180 divided by 2, that is your 90 degree. That means for 90 degree, the supplementary angle will even be your 90 degree, because 90 plus 90 is your 180 degrees. So this is how we can find the supplementary angle for the given angle. Now come your adjacent angle. So what adjacent angles are? So if there are two angles such that they are originating from the same point, that means they are having the common vertex they are having, and one of the common arm they are having. For the two angles, if there are one common arm is there, they are having the common end point, means the starting point vertex is same for both the two angles, and the uncommon arm, a non-common arm, will be in the opposite direction of the common arm. Suppose I am going to say this is your say A, this is your B, this is your C, and this is your D. If I am going to consider this angle and this angle is your angle BAC, and angle CAD. If I am going to consider these two angles, then they will be your adjacent angles. Why? Because they are having the same starting point, that is a vertex for both the two angles is same, that is your A. A is vertex for both the two, and AC is the common arm from both the two angles. For the angle BAC also, we are having one of the arm as AC. For the angle CAD also, we are having a arm AC. That means AC arm is common for both the two angles. And the non-common arm, that is for this angle, AB is the non-common arm, and for this angle, AD is the non-common arm. So your non-common arm is in the opposite direction of your common arm. AC is the common arm, this AB is towards this direction, and this AD is towards this direction of your AC. So what the conditions are, they should have the common endpoint. If the two angles are having the common endpoint, the same endpoint they should have a common arm. One arm should be common for both the two angles, and the non-common arm should be in opposite direction, of common arm. These conditions are fulfilled. If all the three conditions are fulfilled, then we say that these two angles will be your adjacent angles. So what the conditions are, that if there are two angles which is having the common endpoint, which is having one of the common arm, and the other non-common arm is in the opposite direction of your common arm, then such type of angles are known as your adjacent angles. Now if instead of these two angles, if I am going to consider say angle BAD, this angle I am considering, this whole angle, and I am considering angle CAD. If I am considering these two angles, now instead of this angle, now I am considering one of the angle I am considering as your CAD, that means this angle, and another angle is your BAD, that means this angle. These two angles if I am considering, so they are having the common endpoint, that is A is the common endpoint, so first condition is fulfilled. Now the second condition is they should have a common arm also. So for both the two angles, for the angle CAD and for the angle BAD, we are having the common arm AD. So second condition is also fulfilled, that it is having the common arm AD. Now the third condition is that the non-common arm should be in the opposite direction of the common arm. Now if I am going to see the angle BAD In this, the non-common arm is your BA and it is in this direction. It is towards the anti-clockwise direction of your AD. And if I am going to take the angle CAD, then the non-common arm AC is towards the anti-clockwise direction of your AD. That simply means third condition is not fulfilled. Both the non-common arms of both the two angles, it is in the same direction of your common arm. That's the reason these two are not your adjacent angles. They are not your adjacent angles. So if all the three conditions are fulfilled, then only we will be saying that the given two angles are your adjacent angles. Now linear pair of angles. Now if in the adjacent angles, if sum of the adjacent angle is coming equivalent to your 180 degree, if the sum of adjacent angles is 180 degree, then we say it to be a linear pair of angle. Or we can say if there is a line and if any of the ray is originating from the line, then the two angles are formed. This is one of the angle and this is one of the angle. So because it is the angles on the line, so sum of these two angles, if this is the point O, this is the point A, this is the point B and this is the point C. So sum of angle COB, if it is your X, and sum of angle COA, suppose it is your Y. So your X plus Y will be your 180 degree. So such type of angles in which your sum of adjacent angles is coming equivalent to 180 degree, such type of angles are known as your linear pair of angles. Now comes your vertically opposite angles. So if we are going to take any two intersecting lines, these two are the intersecting lines intersecting at point O. This is your AB, this is your CD. In that case, two pair of vertically opposite angles are formed. Total of 4 angles are formed. We can see over here, this is one of the angle, this is one of the angle, this is one of the angle and this is one of the angle. Suppose this is your angle 1, this is angle 2, this is angle 3 and this is angle 4. So 1 and 3, angle 1 and angle 3 will be your vertically opposite angle. Vertically opposite angles, and angle 2 and angle 4. Angle 2 and angle 4 will even be your vertically opposite angles, and vertically opposite angles are equal. That will be proving in this video only. So the two, if we are going to take two lines which are intersecting each other, suppose intersecting at O, then two pair of vertically opposite angles are formed. So angle 1 will be vertically opposite to angle 3 and angle 2 will be vertically opposite angle for your angle 4. So this is all about your pair of angles. Now let's understand what is intersecting lines and what is non-intersecting lines. So if we are going to take any two lines which are going to intersect each other at any of the point, then such type of lines are known as your intersecting lines. If we will be taking any two lines, they are going to intersect only at maximum of 1 point only. They won't be intersecting at more than 1 point. Maximum of 1 point they will be intersecting. But there could be the condition also when the two lines will not intersect each other. If we will be extending it in both the direction up to whatsoever the length we want, then also they are not going to intersect each other. Such type of lines are known as your non-intersecting lines. Why they are non-intersecting lines? They are because your parallel lines and the distance between the two, that means perpendicular distance between these two, will remain same throughout. Whatsoever the distance you will be traveling, either in this direction or in this direction or in both the direction, they will never ever intersect each other because they are parallel lines. So if the lines are intersecting each other at maximum of 1 point only, because it will never ever intersect at more than 1 point, so they will be known as your intersecting lines. And if the lines are not intersecting each other up to whatsoever the length we are extending these two lines, then these type of lines are known as your non-intersecting lines. They are your example of parallel lines. Now some of the axioms we'll be seeing. What axioms are? We have learned in 5th chapter that the statements which we are taking for granted, that means we are not proving it, but they are true for each and every condition. Such type of statements are known as your axioms. So first of the axiom of this chapter, that is axiom 6.1, is if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. See what it is. Suppose this is a line. If a ray stands on a line, this is a line we have taken. And if a ray is standing on the line, In that case, two adjacent angles are formed. This is one of the adjacent angle and this is one of the adjacent angle. Because it is a straight line, so sum of these two angles will be your 180 degree. Just now we have seen in the linear pair of angles that if there are two angles, two adjacent angles if we are taking, and the sum of the two adjacent angles is coming equivalent to your 180 degree, such type of angles are even known as your linear pair of angles. Now suppose this is a point A, this is O, this is B, and this is C. Now over here what we can see is AB is a line, and from on the line AB at point O we have drawn a ray, that is your OC is a ray. Now the two adjacent angles are formed, that is your angle COB and angle COA. These two angles are formed. Suppose this is your X and this is your Y. So these two angles, why they are adjacent angles? Because they are having the common endpoint, that is your O is the common endpoint for angle X also and for angle Y also. They are having a common arm also, that is OC is the common arm for both the angle X also and both the another angle your Y also. And the non-common arm, that is for angle X, OB is the non-common arm, and for the angle Y, your OA is the non-common arm. The non-common arm is in the opposite direction of your common arm. So all the three conditions are fulfilled. So these two are your adjacent angles, and if in the adjacent angles your non-common arms OB and OA are the non-common arms, so if the non-common arms are forming a straight line, then these type of angles are known as your linear pair of angles. And because it is a straight line, so the straight angle, as we have learned, that its straight angle is the angle which is having an angle equivalent to your 180 degree. So sum of these two angles will be your 180 degree. So it is not to be proved. Directly we have taken this statement. That's the reason it is your axiom. So if a ray OC stands on a line AB, then the sum of two adjacent angles so formed is 180 degree. Means X plus Y will be your 180 degree. How these two are adjacent angles just now we have proved, and if the non-common arm of the adjacent angles are forming a straight line, it is even known as your linear pair of angles. Now the second axiom says, axiom 6.2, if the sum of two adjacent angle is 180 degree, then the non-common arms of the angles form a line. Over here it was given that the non-common arms was your adjacent angles. If it is a line, non-common arms of your adjacent angles was forming a line. In first axiom it was given. Then what we had proved is not proved. Basically what we had taken was your that sum of the angles will be 180 degree. Just opposite to it is your axiom 6.2. That means if there are two adjacent angles, one of the adjacent angle is your this and one of the adjacent angle is your 2. Means 1 and 2 are the two adjacent angles. If this is the case, this point I am taking as O, this point I am taking as C. If the sum of adjacent angles so formed is your 180 degree, that means if angle 1 plus angle 2 is 180 degree, it is already given that sum of two angles is your 180 degree, then the non-common arms, these are your adjacent angles and this is the non-common arm, OA and OB are the non-common arms. Non-common arms of the angles form a line. Then in this condition what will happen? Your non-common arms will be forming a straight line. So what these two are saying, that if there is a line and on this line we are taking a ray, then the two adjacent angle formed will be equivalent to your sum of these two will be equivalent to your 180 degree. This was your first axiom. And the second axiom says that if we are going to take any two adjacent angles and if the sum of these two adjacent angles is equivalent to 180 degree, then the non-common arms of this adjacent angles will be your forming a line. So we can check it even. Suppose I have taken these two adjacent angles. This is an angle, this is an angle, angle 1 and angle 2. These angle 1 and angle 2 are even your adjacent angles. Now suppose the measurement of this angle 2 is your 30 degree and angle 1 is your 45 degree. So sum of the angle 1 and angle 2 is your 45 plus 30, that is your 75. It is not equivalent to your 180 degree. That's the reason your non-common arm, this is this and this, they are the non-common arms of the adjacent angles. They are not forming a straight line. Now suppose I am going to take this an example. it is even adjacent angle. Suppose this is angle 1, this is angle 2. So angle 1 and angle 2 are your adjacent angles. Suppose over here this is your 45 degree and this is your say 75 degree. So it will be your 120, angle 1 plus angle 2. Angle 1 plus angle 2 will be a 120 degree. So because it is not equivalent to your 180 degree, that's the reason your non-common arms, this and this are the non-common arms. They are not forming a straight line. Now suppose I am going to take these two adjacent angles. This is one of the adjacent angle. Suppose this is your 30 degree and this is your 150 degree. Now over here the sum of the adjacent angle, this is one of the adjacent angle 150 degree, this is another adjacent angle, that is your 30 degree. Because sum of these two is coming equivalent to your 180 degree, that's the reason for these two adjacent angles the non-common arms will form a straight line. So this is how we can check it even, and then we can conclude that if a ray will stand on the line, then the sum of the two adjacent angles so formed will be 180 degree. And if the sum of the two adjacent angle is 180 degree, then the non-common arms will be forming a line. Because it is depending upon the linear pair of angles, it shows the concept of linear pair of angle. That's the reason these two axioms are even known as linear pair axiom. These two axioms are known as your linear pair axiom. Now let's understand theorem 6.1. The theorem 6.1 says, if two lines intersect each other, then the vertically opposite angles are equal. We know what theorems are. Theorems are the statements which can be proved using your axioms or other statements. If we can prove the statement, then these statements are known as your theorem. So we will be proving it that if two lines intersect each other, then the vertically opposite angles are equal. We have just now seen that when two lines intersect each other, then four angles are formed. That means two pair of vertically opposite angles are formed. Over here, line AB is intersecting with your line CD at point O. So four angles, angle 1, 2, 3, 4 are formed, in which angle 1 and angle 2 are vertically opposite angle, and angle 3 and angle 4 are vertically opposite angle. So we have to prove that angle 1 is equivalent to angle 2 and angle 3 is equivalent to angle 4. The vertically opposite angles are equal. So how we will be proving it? So given to us is that AB and CD lines intersect at O. This is given to us, and we have to prove that angle 1 is equivalent to angle 2 and angle 3 is equivalent to angle 4. This we need to prove. Now over here what we can see is AB is a line, it is given to us. If AB is a line, then sum of angle 2 plus angle 3 will be your 180 degree, because they are your linear pair of angles. If these two are the AB is a line and these two are the angles formed on this line with a ray OD. That means OD is the ray drawn at your line AB. In that case, these two angles so formed will sum up to your 180 degree. This is your linear pair of angle. So we can say that angle 2 plus angle 3 will be your 180 degree. Similarly, CD is even a line. And if CD is a line, that simply means angle 1 plus angle 3 will be your 180 degree, because they are even a linear pair of angle. So by CD, if CD is a line, we can say that angle 1 plus angle 3 will be 180 degree. And if we are taking AB as a line, so we can say angle 2 plus angle 3 is 180 degree. So these two statements we have taken because they are your linear pair of angles. So angle 1 plus angle 3 will be 180 degree and angle 3 plus angle 2 will be 180 degree. Suppose they are equation number 1 and equation number 2. So we can see that in these two equations, your RHS part is same, that is a 180 degree. So we can equate both the two equations, because things which are equal to the same thing. This thing is equivalent to 180 degree. This thing is even equivalent to 180 degree. So things which are equal to the same thing, they are even equal to one another. So angle 1 plus angle 3 will be equivalent to your angle 3 plus angle 2. Now over here angle 3 and angle 3 both are going to cancel, they are same. So angle 1 will be equivalent to your angle 2. From this equation we can say your angle 1 is equivalent to angle 2, and that was to be proved. Similarly, we can prove that angle 3 is even equivalent to your angle 4. How we can prove it? Now see, if we will be considering the line AB, this line AB we are considering, so your angle 2 plus angle 3 will be your 180 degree, because it is your linear pair of angle. This line AB we are considering, so this angle will be 180 degree. So angle 2 plus angle 3 will be 180 degree. Now we are considering CD as the line. Then in that case, this angle will be 180 degree because it is a line. So angle 2 plus angle 4 will be 180 degree because they are linear pair of angles. Now we can see again in these two equations, your RHS part is same. So we can equate these two equations. Suppose this is equation number 1, this is equation number 2. So we can equate these two equations. So angle 2 plus angle 3 will be equivalent to angle 2 plus angle 4. And both are going to cancel. Angle 3 will be equivalent to your angle 4. And that was to be proved. So we have just now proved that angle 1 is equivalent to angle 2. Similarly, we have proved that angle 3 is equivalent to angle 4. So this was to be proved. So this is how we can prove that if two lines intersect each other, then the vertically opposite angles are equal. Now let's see some of the questions from the exercise. Say question number 2. In figure 6.14, lines XY and MN intersect at O. First of all, we will be making the diagram. Figure will be making, this is your X, this is your Y. Over here, this angle is 90 degree. It is point P. This point is O. Here there is a line. This angle is A. This angle is B. And this angle is C. And this point is M. This is N. This is your N. Now it is given to us that XY and MN intersect at O. That means it is given that XY and MN are straight lines. It is given to us. And if angle POY is 90 degree, it is also given to us. And A is to B is your 2:3. It is also given. We have to find the angle C. We have to find this angle. Now see, if angle A and angle B ratio is 2:3, so we can assume angle A to be your 2x and angle B to be your 3x. Right? Now, because XY is a straight line, so sum of A plus B plus your 90 degree, this angle, it will be equivalent to your 180 degree. So we can take angle A plus angle B plus angle POY, which is given equivalent to your 90 degree. It is 180 degree because XY is a straight line. Now from here, angle A could be written as 2x. Angle B could be written as 3x. This is your 90. It is equivalent to 180 degree. This 90 will go in the right hand direction. So it will be 180 minus 90. 2x plus 3x will be your 5x. So 5x is equivalent to 180 minus 90. That is your 90 only. So value of x will be 90 upon 5. 5 1 is 5 and 5 8 is 40. So value of x is 40. And what the value of A was? Value of angle A is your 2x, that is 2 multiplied by 18, that is your 36. And angle B will be your 3x, that is 3 multiplied by 18, that is your 54. So angle B is 54 and angle A is 36. Now we can see that MN is even a straight line. So angle B plus angle C will be 180 degree because MN is a straight line. So angle B plus angle C will be your 180 degree. Just now we have seen that the angle B is your 54 degree. So 54 plus angle C is 180 degree, or we can say angle C will be 180 minus 54. That is your 6 here, 7 to 20, 126 degree will be the measure of your angle C. This is how we can find it out. Now let's see one more question. Say question number 4. In figure 6.16, x plus y is equivalent to your w plus z. Then prove that angle AOB is a line. So first of all, we are making the figure. This is a straight line. This is your one of the ray. This is another ray. This is x. This is y. This is z. And this is w. This point is A, here it is your C, here it is your B, and here it is your D. This is the figure. Given to us is that x plus y is equivalent to W plus Z. It is given to us. Now, if it is given to us, we need to prove that AOB is a straight line. Now, see, this is your point O. So at a single point, the sum of all the angles is your 360 degree. We know that this is a complete angle and sum of all these angles will be your 360 degree. So we can write that x plus y plus z plus w is your 360 degree, because it is a complete angle. Angle at a point is your 360 degree. Now it is given to us that x plus y is equivalent to your w plus z. So if x plus y is equivalent to w plus z, instead of w plus z, we can write x plus y also. So instead of w plus z, we will be writing your x plus y. It is equivalent to 360 degree. So if we will be solving it further, x plus x will become 2x plus 2y is 360 degree. 2 could be taken common. It will be x plus y is equivalent to 360 degree, and we can say value of x plus y will be 360 divided by 2, that is your 180 degree. So if x plus y is 180 degree, so we can see over here these two are the angles, angle x and angle y, and just now we have seen that if the sum of adjacent angles is equivalent to your 180 degree, then the non-opposite arms will be forming a straight line. That simply means AB will be a straight line. This is how we can prove it. Now let's understand the concept of parallel lines and a transversal. So if there are two or more than two lines, suppose I am saying that this is one of the line, this is one of the line, and this is one of the line, and there is one more line which is intersecting these lines at distinct points. Suppose this is the point where it is intersecting. Suppose this is your line L, this is M, this is N, and this is your Q. So line Q is intersecting the line L and line M and line N at your distinct points. That is, suppose it is your A point, this is your B point, and this is your C point. So this type of line which is intersecting two or more than two lines at distinct points is known as your transversal. So here we will be taking the case when this transversal is intersecting any two lines. Suppose I have taken a line L and line M, and the line N is intersecting the line L and M. Suppose at the point your P and the point Q. Now, when it will be intersecting the given two lines at two distinct points, so we can see over here that 8 angles are formed. This is one of the angle. These are 4 angles at this point P, 4 angles at the point Q. Suppose this is angle 1, this is angle 2, this is 3, this is 4, 5, 6, 7 and 8. These 8 are the angles. Then what is your exterior angles? So angles outside, that means angle 1, angle 2, angle 7 and angle 8 are known as your exterior angles. The angle 1, angle 2, angle 7 and angle 8 are known as exterior angles. Now the interior angles will be angle 3, angle 4, angle 5 and angle 6, which is inside these two lines. So these will be known as your interior angles. So angle 3, angle 4, angle 5 and angle 6 are your interior angles. Now comes your corresponding angle. What corresponding angles are? Angle 1 and angle 5 are the corresponding angles. Angle 2, angle 6 are corresponding angle. Angle 4, angle 8 is corresponding angle, and angle 3 and angle 7 is corresponding angle. So we will be taking as angle 1 and angle 5. These are corresponding angle. 1 is corresponding to your 5. Angle 1 and angle 5 is corresponding angle. Angle 4 and angle 8. This angle 4 and angle 8 is corresponding angle. Angle 2 and your angle 6 is corresponding angle. And angle 3 and angle 7 are known as your corresponding angles. So 4 pair of corresponding angles will be formed when one of the transversal will be intersecting any two given lines at distinct points. So these are the pair of your corresponding angles. Now comes your alternative interior angles. So see over here, this angle 4 and this angle 6 making Z. So angle 4 and angle 6, they are in the interior. So that's the reason they are known as alternate interior angles. So angle 4 and angle 6. they are alternative interior angles. Similarly, angle 3 and angle 5. This angle 3 and angle 5 is known as your alternative interior angle. Angle 4 and angle 6 is the alternative interior angle, and angle 3 and angle 5, they will be alternative interior angles. Now comes your alternative exterior angles. So take it outside, then angles in the outside. So angle 1 and angle 7. We are making Z, so angle 1 and angle 7, they are in the outside, so they are alternative exterior angle. Angle 1 and angle 7, alternative exterior angle, and angle 2 and angle 8. Angle 2 and angle 8, they are the pair of your alternative exterior angle. Now comes the interior angles on the same side of the transversal. This is the transversal, N is the transversal. Angle 4 and angle 5, it is in the same side of the transversal. Similarly, angle 3 and angle 6, they are the interior angles in the same side of the transversal. Interior angle means your 3, 4, 5, 6 are the interior angles. And if we are talking about interior angles on the same side of the transversal, so angle 4 and angle 5 will be the interior angles on the same side of the transversal, angle 4 and angle 5, and angle 3 and angle 6. These will be the interior angles on the same side of the transversal. This is how we can name all these angles. Now, interior angles on the same side of transversal is even known as your consecutive angles. They are even known as your allied angles, and they are also known as your co-interior angles. These angles are even known as your consecutive angles or allied angles or your co-interior angles. This is a simple condition where your L and M are any two given lines. It may be the intersecting lines, it may be your parallel lines, it could be any of the condition. Whenever your transversal will intersect any two given lines at two distinct points, then these 8 angles will be formed. And these angles could be named like your exterior angles, interior angles, corresponding angles. All these will be the naming: alternative interior angle, alternative exterior angles, or the interior angle on the same side of the transversal. Now let's see some more axioms. That is your axiom 6.3. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. Over here, so we have not taken that these two lines are parallel. It could be parallel, it could be intersecting also. But if the two lines are parallel, these two lines are parallel to each other, this is your L, this is your M, and it is the transversal, say N, then the pair of corresponding angles is equal. So first of all, we are naming it 1, 2, 3, 4, 5, 6, 7 and 8. So just now we have seen that what corresponding angles are. Angle 1 and angle 5, they are corresponding angle. So if lines are parallel and if a transversal is cutting or intersecting the parallel lines at two distinct points, then the pair of corresponding angles is equal. It is the axiom, and this axiom is even known as your corresponding angle axiom. So according to it, angle 1 will be equivalent to your angle 5 because it is corresponding angle. Angle 4 and angle 8 are corresponding angle. So angle 4 will be equivalent to angle 8. Angle 2 and angle 6 are corresponding angles. So angle 2 will be equivalent to angle 6. Angle 3 and angle 7 are corresponding angles. So angle 3 will be equivalent to angle 7. So if there is a transversal which is intersecting two lines which are parallel to each other, then each pair of corresponding angles will be equal. Then this condition is going to be satisfied. It is not to be proved, but it is true for each and every condition. That's the reason we have taken it as your axiom. Now the next axiom is your 6.4. If a transversal intersect two lines such that a pair of corresponding angles is equal, then the lines are parallel to each other. Over here it is given that it is not given to us that the lines are parallel. Only it is given that angle 1 is equivalent to angle 5, angle 4 is equivalent to angle 8, 2 is equivalent to 6 and 3 is equivalent to 7. If any one of these is given to us, that means if any one pair of corresponding angle is equivalent, it is given to us, then we will say that the two lines are parallel to each other. So what the first axiom was saying, it was saying that if there are two parallel lines and if a transversal is intersecting two parallel lines, then all the pair of your corresponding angles will be equal. If L and M is parallel and N is intersecting these two parallel lines, then these corresponding angles will be equal. Now the next axiom says that if there are two lines which may be intersecting, which may be parallel, it is not given to us. If there are two lines and the corresponding angles are equivalent to each other, in that case these two lines will be parallel to each other. Now let's understand some of the theorems. Theorem 6.2. If a transversal intersects two parallel lines, then each pair of alternative interior angles is equal. That means if there are two parallel lines are there, we are assuming that the L and M, these two are the lines which are parallel to each other, and a transversal N is intersecting these two lines L and M at distinct points, then the pair of alternative interior angles will be equal. This we have to prove. That means simply it is given that L is parallel to F. We have to prove that the alternative interior angles, that means angle 3 is equivalent to angle 5. This we have to prove. And angle 4 is equivalent to angle 6. This is equivalent. This we have to prove. So what is given to us is that L is parallel to M. It is given to us. And we have to prove that angle 3 is equivalent to angle 5 and angle 4 is equivalent to angle 6. This we have to prove. Now in the proving, what we will be doing is, see over here, just now we have seen in the axiom that if lines are parallel, then the corresponding angles will be equal. So if lines are parallel, it is already given to us that lines are parallel. So pair of corresponding angles will be equal. That we can automatically conclude by your corresponding angle axiom. So we can say that angle 2 will be equivalent to your angle 6 because they are corresponding angle. Angle 2 and angle 6, they will be equal because they are your corresponding angles. Now we can see over here that angle 2 and angle 4, they are vertically opposite angles, and we have just now seen that the vertically opposite angles are equal. So angle 2 will be equivalent to angle 4 because they are vertically opposite angle. So we have taken angle 2 equivalent to angle 4 as they are your vertically opposite angle. Suppose this is your equation 1 and this is your equation number 2. So from the equation number 1 and 2, we can see that angle 2 is equivalent to angle 6 and angle 2 is equivalent to angle 4. So we can equate both of them because both of their LHS part is equal. So from these two equations, we can say that angle 6 will be equivalent to angle 4. And that was to be proved that angle 4 is equivalent to angle 6. So we have just now proved that the pair of alternative angle is equal. Similarly, we can say that angle 1 and angle 5, they are again corresponding angles. Angle 1 and angle 5 are corresponding angles, so they will be equal. So we will be taking that angle 1 is equivalent to angle 5. Reason being they are corresponding angles. Corresponding angles they are, so they will be equal. And now we know that angle 1 and angle 3, they are vertically opposite angle, so they will be equal. So angle 1 will be equivalent to angle 3. They are vertically opposite angle. If this is your equation number 3 and this is your equation number 4, so from equation number 3 and equation number 4, we can conclude, because their LHS part is same, so we can say that angle 5 will be equivalent to angle 3. That means pair of your alternative interior angle, angle 3 and angle 5 are equal. So this is how we can prove that if lines are parallel, then the pair of alternative interior angles will be equal. Now the next theorem is theorem 6.3. If a transversal intersect two lines such that a pair of alternative interior angles is equal, then the two lines are parallel. Just opposite to it. Over here, it was given that the lines were parallel and we were to prove that the alternative interior angles will be equal. Here it is given that the pair of alternative interior angles is equal. We have to prove that the line L and M are parallel. So what is given to us is that angle 3 is equivalent to angle 5. It is equal. It is given to us. Similarly, angle 4 is equivalent to angle 6. It is equal. It is even given to us that these two pair of alternative interior angles is equal. So given is angle 3 equivalent to angle 5, it is given. Angle 4 is equivalent to angle 6, it is even given. we have to prove that line L is parallel to line M. This we need to prove. Now in the proving, what we will be doing is, first we are taking this case. Over here it is given that angle 3 is equivalent to angle 5. It is given that angle 3 is equivalent to angle 5. It is given to us. Now angle 3 and angle 1, they are vertically opposite angle. So angle 3 will be equivalent to angle 1 because they are your vertically opposite angles. Now from the equation 1 and 2, what we can see that the LHS part of both the two equation is same. So angle 5 will be equivalent to angle 1 because angle 3 was equivalent to angle 5, angle 3 was equivalent to angle 1. So if there is something, if two things are there which is equal to the same thing, then they both will be equal to each other. So angle 1 will be equivalent to angle 5. Now if angle 1 is equivalent to angle 5, we can see over here that 1 and 5 are your corresponding angle, and we know that if corresponding angles are equal, then lines are parallel. Whatsoever the axioms we have already learned, we can use these axioms in proving these type of theorems. So these axioms directly will be taking as a statement, and we can prove it, these theorems, using those axioms. So we can say that because the corresponding angles are equal, this we have just now proved. So because a pair of corresponding angles are equal, so if pair of corresponding angles are equal, lines are parallel as per your corresponding angle axiom. So that's the reason your L will be parallel to your M, and hence proved. This is how we can prove it. Now let's see some more theorems. Theorem 6.4. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. That means it is given to us that L is parallel to M. Then the pair of interior angles on the same side of the transversal will be angle 4 and angle 5, and your angle 3 and angle 6. That means we need to prove that if line L and M is parallel to each other, then angle 4 plus angle 5 will be 180 degree, and angle 3 plus angle 6 will be your 180 degree. So given to us is that L is parallel to M, it is given to us, and we have to prove that angle 4 plus angle 5. That means interior angle on the same side of the transversal is total is your 180 degree. So angle 4 plus 5 is 180 degree, and angle 3 plus angle 6 is your 180 degree. This we have to prove. Now how will we be proving it? Over here we can see that L is a line. If L is a line, so angle 3 plus angle 4 will be your 180 degree because it is your linear pair of angle. This is a line and these two are the angles formed on the line. So angle 3 plus angle 4 will be your 180 degree as they are your linear pair of angles. And we know that angle 3 and angle 5, they are your alternative angles. And just now we have proved that if the lines are parallel, then the alternative interior angles are equal. So we know that angle 3 will be equivalent to your angle 5 because they are your alternative interior angles. So angle 3 will be equivalent to angle 5 as they are alternative interior angles. Now if this is your equation number 1, this is your equation number 2. So from equation number 1 and equation number 2, what we can say is, instead of angle 3, we can write angle 5. So in equation number 1, instead of angle 3, we will be writing angle 5. So this angle 3 has changed to angle 5, and this plus angle 4, it is equivalent to 180 degree. And this was to be proved that angle 4 plus angle 5 is 180 degree. Similarly, what we can say is that angle 4 is equivalent to angle 6 because they are alternative interior angles. As just now we have said that angle 3 was equivalent to angle 5 as they were alternative interior angles. Similarly, angle 4 will be equivalent to your angle 6 as it is even an alternative interior angle. Alternative interior angles they are. Now, what we can conclude from here is from equation number 1, from equation number 1 and 3. We are taking equation number 1 and equation number 3. Here in the equation number 1, instead of angle 4, if we will be replacing angle 6, so it will become angle 3 plus angle 6 is equivalent to 180 degree. And this was to be proved that the sum of interior angles on the same side of the transversal is supplementary. It is equivalent to your 180 degree. So if lines are parallel, then sum of the interior angles on the same side of the transversal will be 180 degree. Now the next theorem is theorem 6.5. If a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then two lines are parallel. Here it is given to us that angle 4 plus angle 5 is 180. It is even given that angle 3 plus angle 6 is 180. We have to prove that line L is parallel to your line M. Now what is given to us is that sum of interior angles on the same side of the transversal is 180. So angle 3 plus angle 6 is 180 given, and angle 4 plus angle 5 is 180, it is also given to us. We have to prove that L is parallel to M. So how we will be proving it? First of all, we are taking this angle 3 plus angle 6 is 180. It is already given to us that angle 3 and angle 6, sum of these two angles is 180 degree. It is given. Now we know that L is a line, and if L is a line, so angle 3 plus angle 4 will be 180 degree because it is your linear pair of angle. So angle 3 plus angle 4 will be your 180 degree as it is your linear pair of angle. If this is your equation number 1 and this is equation number 2, so right hand side of both the two equations are same, so we can equate both the two equations. So we can say from equation number 1 and equation number 2 that angle 3 plus angle 6 will be equivalent to angle 3 plus angle 4 because both were equivalent to your 180 degree only. Now over here we can see angle 3 and angle 3 both are going to cancel, so angle 6 will be equivalent to your angle 4. Now if we are going to see angle 6 and angle 4, we have proved that these two angles will be equal. Now if these two angles are equal, so we can see they are alternative interior angles. Angle 4 and angle 6 is your alternative interior angles. So we have proved that alternative interior angles are equal, and we know that if alternative interior angles are equal, then lines are parallel. So we can conclude that L will be parallel to your M. This is how we can prove the theorems. Whatsoever the axioms of theorems we have proved earlier, we can use those statements in proving your other theorems. Till now we have seen that if there are two lines which are parallel to each other and one of the transversal is intersecting these two lines at distinct points, then the pair of corresponding angles are equal, pair of alternative interior angles are equal, and the sum of the interior angles on the same side of the transversal is 180 degree. Similarly, if in any two lines which is not given equivalent to parallel, if the corresponding angles are equal, or if alternative interior angles are equal, or if sum of the interior angles on the same side of the transversal is equal, then we can say that the two given lines are parallel to each other. Now let's understand the lines parallel to the same line. If suppose there are two lines, this line is your L, it is parallel to your this line, say M, and if there is one more line N which is parallel to your M, that means L and N both are parallel to your line M. In that case, how we can say that these two lines will even be parallel to each other? That means L and N will also be parallel to each other. How we can find it out? How we can prove it? So let's see the theorem. Lines which are parallel to the same line are parallel to each other. That means we are assuming over here that L is parallel to N. Similarly, we are assuming that M is parallel to N. That means these two lines are there and these two lines are parallel to this common line N. We have to prove that L and M both are parallel to each other. So what is given to us is that L is parallel to N. That means L and N, these two lines are parallel to each other. Along with that, it is even given that M is parallel to N. That means M and N, these two lines are also parallel to each other. We have to prove that L is parallel to M. We have to prove that L and M both are parallel to each other. These two lines are parallel. This we have to prove. It is already given that L and N is parallel and M and N is parallel to each other. Now what we can see in these two lines, if we are going to see the line L and line N, these two lines if we are going to consider, because just now we have said that it is given to us that L and N, they are parallel to each other, and if lines are parallel, we know the corresponding angles are equal. So this angle 1 will be equivalent to angle 3 because they are the corresponding pair of angles. So angle 1 will be equivalent to angle 3 because your line L is parallel to N. Now if this is the condition, now again second condition is given to us is your M is parallel to N. It is also given that line M is parallel to N, and if these two are parallel, then your angle 2 will be equivalent to angle 3, because for these two lines, angle 2 and angle 3 is even your corresponding angles. So angle 2 will be equivalent to angle 3 because M and N both are parallel to each other. Now if this is your equation number 1 and this is your equation number 2, so what we can see is the RHS part is angle 3. So we can equate these two equations. So from equation number 1 and equation number 2, we can say that angle 1 is equivalent to angle 2 because both of them are equivalent to your angle 3. So what we can say is that angle 1 is equivalent to angle 2. And if angle 1 and angle 2 are equal to each other, then for these two lines, L and M, they are corresponding angle, and we know that if in any two lines corresponding angles are equal, then the lines are parallel. So we have just now proved that angle 1 is equivalent to angle 2, and that simply means pair of corresponding angles are equal because they are corresponding angles for the line L and M. So we have just now proved that the pair of corresponding angles are equal, and we know that if corresponding angles are equal, lines will be parallel. That means L will be parallel to M also. Why it is so? By the converse of corresponding angle axiom, we can conclude that if pair of corresponding angles are equal, lines will be parallel to each other. So it was given to us that L is parallel to N. It was given, and it was even given that M was parallel to N. So if there are two lines which are parallel to the same line, in that case these two lines will even be parallel. That means L will be parallel to your M. This is how we can prove it. Now let's see one of the question from your exercise 6.2. Say question number 5. In the given figure 6.32, if AB is parallel to CD, given to us is AB is parallel to CD, angle APQ, it is 50 degree, and angle PRD is 127 degree. Find X and Y. What's the figure? These are two lines, that is your AB and your CD. These are parallel, it is given to us. Then here is a point P. This is point P. This is Q. This is R. This angle is 50 degree. This angle is 127 degree. This is X and this is Y. We have to find the values of your X and Y. Now over here what is given to us is AB is parallel to CD, it is given to us. Now we can see over here if these two lines are parallel and it is the transversal. This is your transversal. In that case your this angle 50 and this angle X, these are your alternative angles. That means angle X will be equivalent to your 50 because they are alternative angles. Line AB is parallel to CD and it is making your Z. So it is your alternative interior angle. That's the reason X will be equivalent to your 50 degree. Reason being they are alternative interior angles. Now we can see over here at this point R, your CD is a straight line. At this point R, it is making an alternate. This is your linear pair of angles. That means this is 127. And suppose I am going to say this angle. Now angle PRD plus angle PRQ. Angle PRQ will be 180 degree because they are linear pair of angles. Linear pair of angles. So sum of these two angles will be your 180 degree. Now this angle is given to us as 127 degree. And we are taking PRQ as angle PRQ only. Sum of these two is 180 degree. So angle PRQ will be 180 minus 127. So it will be 3. And here it is 53 degrees. So this angle will be your 53 degrees. Now if this is your 53 degrees, we know that PQR is a triangle and sum of all the angles of a triangle is your 180 degree. So we can find the value of y from here. So angle x plus angle y plus angle this is your angle PRQ. It will be on 180 degree. Angle x is your 50 degree. Just now we have proved it. 50 plus angle y plus angle PRQ is a 53 degree. It is equivalent to 180 degree. Now angle y will be from here, angle y plus 50 plus 53, it will be 103 degrees. It is equivalent to 180, and we can say y will be 180 minus 103, that is 77 degree. So this is how we can find it out. In these type of questions, could be so many methods of finding these type of questions. So this is how we can solve these type of questions. Now let's understand the angle sum property of a triangle. We know that the sum of all the angles of a triangle is 180 degree. Now let's see how we can prove it. So theorem 6.7 says the sum of the angles of a triangle is 180 degree. That means if there is a triangle PQR and its angles are your angle P is your 1, angle Q is 2 and angle R is your 3, then sum of angle 1 plus 2 plus 3 will be your 180 degree. Now how we can prove it? Given to us is that there is a triangle PQR, it is given to us, and we have to prove that angle 1 plus angle 2 plus angle 3 is your 180 degree. Now what we will be doing is, we will be drawing a line XY which will be parallel to your QR and which will pass through your point P. So construction we will be doing is, draw XY parallel to your QR which will pass through your P. Because it is your construction, that's why it is through your dotted lines. Now we can see over here, by construction we have taken XY parallel to your QR. Now angle 4 will be equivalent to your angle 2 because these two lines are parallel, and if the lines are parallel and this is your transversal, this we can take as the transversal, then angle 4 and angle 2, they are alternative interior angles. Angle 4 is alternative interior to your angle 2. That's the reason angle 4 will be equivalent to angle 2. Similarly, if we will take XY and QR as parallel lines and we will take this as your transversal, in that case angle 5 will be equivalent to angle 3 because they are again alternative interior angle. Angle 5 and angle 3, they are alternative interior angles. That's the reason angle 5 will be equivalent to your angle 3. Now suppose this is your equation number 1 and this is your equation number 2. Now we can see over here we have taken XY as a line, and at any point on the line, if we are going to make the angles, then the sum of all the angles will be of 180 degree. That means at point P, which all angles are formed? Angle 4, angle 1 and angle 5 are the points, which are the angles which are formed at point P of the line your XY. That's the reason the sum of all these three angles will be your 180 degree. So we can say that XY is a line. So angle 4 plus angle 1 plus angle 5 will be your 180 degree because it is a straight line. Now this is suppose your equation number 3. Now if we are going to see equation number 1, equation number 2 and equation number 3. So in this equation number 3, what we will be doing is, from equation number 1, angle of 4 could be written equivalent to your angle of 2. So instead of angle 4 in equation number 3, we can replace this angle 4 by your angle 2. So instead of angle 4, we have written angle 2. Angle 1 we have written as it is. Now angle 5, from equation number 2, angle 5 could be written equivalent to your angle 3. So we will replace this angle 5 by your angle 3. So from equation 1, 2 and 3, what we can say is angle 2 plus angle 1 plus angle 3 is equivalent to your 180 degree. In the equation number 3, we have replaced angle 4 by your angle 2 and angle 5 by angle 3 because we had already proved that angle 4 is equivalent to angle 2 and angle 5 was equivalent to angle 3. So we can say that angle 2 plus angle 1 plus angle 3 is equivalent to your 180 degree, and that was to be proved. So we will write it as hence proved. So this is how we can prove the angle sum property of a triangle. Now let's see exterior angle property. According to your exterior angle property, if a side of a triangle is produced, that means we have taken a triangle PQR, we had produced this side QR up to your say S point, it is extended, so it is produced. then the exterior angle so formed is equal to the sum of the two interior opposite angles. Now, if we will be producing this QR, then this is the exterior angle. Exterior angle is your angle 4. So we have to prove that angle 4 is equivalent to your sum of interior opposite angle. So interior opposite angle for this will be your angle 1 and angle 2. So we have to prove that angle 4 is equivalent to angle 1 plus angle 2. So what is given to us is that triangle PQR is there, it is given, and the exterior angle, angle 4 is your exterior angle, it is given to us. We have to prove that angle 4 is equivalent to angle 1 plus angle 2. Now how we can prove it? Just now we have seen that sum of all the angles of a triangle is 180 degree. That means angle 1 plus angle 2 plus angle 3 will be your 180 degree. This is your equation number 1 and it is from your angle sum property of a triangle. Now, because QS, this is your straight line is there. So at point R, the sum of angle 3 plus angle 4 will be your 180 degree because it is your linear pair of angles. Angle 3 plus angle 4 because it is a straight line. So angle 3 plus angle 4 will be your 180 degree. They are linear pair of angles. This is your equation number 2. In the equation number 1 and equation number 2, your RHS part is your 180, which is same. So we can equate both the two equations. So we will be equating it. So LHS part over here, angle 1 plus angle 2 plus angle 3 we have taken here, angle 1 plus angle 2 plus angle 3. Now it is equivalent to 180, it is even equivalent to 180. So we have equated this equivalent to your angle 3 plus angle 4. So it is equivalent to your angle 3 plus angle 4. Now angle 3 is going to cancel. So it will be angle 1 plus angle 2 is equivalent to your angle 4, which was to be proved that exterior angle is equivalent to your sum of interior opposite angle. So this is how we can prove your angle sum property and your exterior angle property. Now let's see one of the question from your exercise 6.3. Question number 4 we are seeing. So this is your question number 4. In the figure, if lines PQ, RS intersect at point T such that angle PRT is your 40 degree, angle RPT is 95 degree, and angle TSQ is 75 degree. Then find the value of angle SQT. The figure is like this. It is a line. Over here, this is like this. Then this, and then this is the figure. This is point R. This is point P. This is your T. This is S, and this is Q. This angle is equivalent to 40 degree. This is 95 degree. This is your 75 degree, and we have to find SQT. SQT, this angle we need to find it out. So let's solve it. Just now we have seen that the angle sum property, that means sum of all the angles of a triangle is 180 degree. So if we will be considering triangle PRT, it is a triangle. So sum of all these three angles will be your 180 degree. So suppose this is your angle 1. And this is your angle 2. We have to find the value of angle 2. So we can say that 95 plus 40 plus angle 1 will be your 180 degree. This is we are considering triangle PRT. In triangle PRT, angle P plus angle R plus angle T, that is your 95 plus 40 plus this angle we have named as your angle 1, it will be equivalent to your 180 degree. So if we will be adding it, 135 plus angle 1 is your 180 degree. So we can say angle 1 is 180 minus 135, or we can say angle 1 will be your 45 degrees. So this angle is 45 degrees. Now if this is 45 degrees, this angle will even be 45 degrees because they are vertically opposite angle. So if this is angle 1, this is angle 2, and suppose this is your angle 3. So angle 1 will be equivalent to angle 3 will be equivalent to 45 because they are vertically opposite angles. So angle 1 is 45, that's the reason angle 3 will even be 45. Now we will be considering triangle. In triangle STQ, again sum of all the angles of a triangle will be 180 degree. So angle 3 just now we said it is 45 degree. plus it is your 75 degree, and angle 2 which we have to find, it will be your sum will be your 180 degree. So it will be 120 plus angle 2 is 180 degree. So we can say angle 2 will be 180 minus 120, that is 60 degree. So the value of angle SQT, that is angle 2, will be your 60 degrees. This is how, using your angle sum property of a triangle, we can solve these type of questions. This is all from this chapter. Hope it is clear to you. Soon we'll be coming with more videos on other chapters of your maths curricular of class 9th. I hope you are understanding what I'm trying to explain it to you. If you have not yet subscribed my channel, please do subscribe it. Thank you.